Welcome, pool guys and gals, to the Let's Talk About Pools podcast, where your host, Lauren Broom, will take a splash into many topics in the pool industry to educate all aquatic professionals. Listen in, and you just might be surprised what you'll learn. So let's jump right in.
Welcome, everybody, today to the Let's Talk About Pools podcast. And on today's episode 37, I got to speak with John Psaroudis of Aquionics, and we spoke about UV or ultraviolet disinfection and how it's useful. What are the good things about it? What are some of the downsides to it? So if you really want to learn more about UV disinfection, this is the episode for you. I also want to say thank you to my sponsors, my upfront sponsor of Skimmer. Please check them out. They're awesome and they love continuing education through the podcast. And I also want to say thank you to my other co-sponsor, which is Raypack, and check them out as well. They will have an ad in the middle of this podcast episode, so you can get their information and check them out as well. Heaters and pool heaters and different things like that, go to their website. But I want to say thank you to both of my sponsors. And let's jump right into this episode, guys.
This is Skimmer, software for the modern pool professional. What can you do with Skimmer? See all your customers on a map, build service routes quickly, and let Skimmer optimize them for you. Access customer information, including contact details and full service history, anytime and anywhere. Customize work orders to track jobs like repairs and filter cleanings. Email your customers when you complete a service. You can include service details and on-site photos. Does your customer need a part? Add it to the shopping list and track it from purchase to installation. Skimmer will even remind you what parts you need for the day, and you can mark them as installed right when you're finished. Skimmer doesn't just store your service history, it helps you get paid. We integrate with QuickBooks Online for fast, easy invoicing. And we've got more billing options coming soon. All that's just the beginning. Go to getskimmer.com to watch our demo video, check out our online tutorials, and see if Skimmer is right for you.
Hello, welcome to Let's Talk About Pools today. And today's episode is going to be my guest, John Psaroudis from Aquionics, talking about UV disinfection today. Welcome, John.
Thank you, Lauren. It's great to be here.
So tell me a little bit about you, John, and your company, Aquionics.
So Aquionics is a company that specifies UV disinfection for any kind of market. Swimming pools happens to be one, and that's the market that I work in. We also treat wastewater, drinking water, pharmaceutical grade water, any type of water for disinfection. And we do low pressure, medium pressure. We also carry a full array of the parts and pieces and the systems in our Charlotte-based office in Charlotte, North Carolina, which is where I work out of. And we do just about any type of water disinfection with ultraviolet light.
Awesome. So tell the audience that's listening, which is going to be made up of a variety of people, about UV disinfection, how it works on pool water, why they might want to use it.
Okay, so first, let me just tell you that there are two types of UV. There's low pressure and medium pressure UV. So the drinking water industry, they use low pressure, which is just for disinfection. And we've got a disinfection dose of 254 nanometers of light. For swimming pools, we use medium pressure UV, which gives you the entire spectrum of light from 0 nanometers up into the 400 range. And the reason we do that is because the disinfection happens at 254 nanometers. But as you know, in indoor facilities, we want to keep the dose around 60 millijoules for the combined chlorine and things like that. So it's not only disinfection. So the way we make the UV light is we have a stainless steel chamber, which is like a tank with flanges that fits right on your return line after the water goes through your filter. And before the heater and before you put the chemicals and things like that in. So we put the tank in line. Inside the stainless steel tank is a hollow quartz or glass sleeve, and inside that is the light bulb. So the light bulb has 1 drop of mercury inside, and we we put an electrical current in from both sides, and it excites the mercury, and it makes an arc inside there, which produces the ultraviolet light. So people in the industry don't like to say light bulb or They say arc tube because it causes the arc inside the tube. So you've got light inside there, and the water flows through there from the filter, and the ultraviolet light kills and deactivates anything, I can say 99.99% of all bacteria and virus. The reason I can't say 100% is there may be something we don't know about, just like when we had this COVID thing. We didn't know about COVID at the time, but the UV light actually would kill that, but we don't know about something that the ultraviolet light may not deactivate. So that's pretty much what it is. It's just a light bulb, and the UV light is somewhere between visible light on the spectrum and X-ray. So that's what we do, and it kills everything as the water passes on the first pass.
When you say kill the microorganisms, how does it kill it?
So I'm going to take you back to your high school days. I know we just talked about how old we are, and I'm way older than you. But I can tell you that in high school, they taught you in biology the old Watson and Crick double helix molecule that spirals down. So what happens is the UV light breaks that apart and renders it ineffective.
Wow, that's really cool. We're going right back to our audience. Think back to high school biology here.
Right.
And remember the double helix.
That's right. Watson and Crick. I even pulled that one out too. The Watson and Crick.
Otherwise, if you know movies in the audience, go back to Jurassic Park, where they talked about DNA in there and how they spliced frog DNA or something in there. Right. But it's the same idea. We're breaking apart that double helix of the DNA of the microorganisms, which cause illness in water. Awesome. Right. So I know some states like Florida will require like splash pads to be on UV as secondary disinfection. Can you explain a little bit what the benefit is of the secondary disinfection on a facility like that?
Yeah, so two things. One is for a splash pad, we only have one chance to treat that water before a young child will sit there and drink it out of a fountain or out of it spraying out of a nozzle, or your son's shooting somebody and the kid's drinking the water. So the ultraviolet light will kill everything before it goes there. Whereas in a pool, we count on the recirculation rate. So I told you we put it on the UV, or we put the UV after the filter and before all the other stuff, and it goes out to the pool, but you may have a 200 or 300,000 gallon tank of water. So we're only treating the water as it goes through the system, whereas on a spray pad, it's going from the UV out to the pad. So it has to be drinking water grade when it goes out there. So you have chlorine, it's treating the water in the tank. And then as it goes from the tank to the UV and out to the site, and where a kid could possibly drink it, then you're 100% guaranteed that there's nothing in there that could cause them to get sick and things like that. So they use it as secondary disinfection. It's just a backup, for that water.
So basically, because those type of facilities, the children are younger, maybe not potty trained, but they do like, ooh, I can drink this water. So you have a higher risk of recreational water illness outbreaks. That's awesome explanation for the secondary disinfection. Thank you, John. What is the required dose for pool disinfection or water disinfection for recreational facilities?
Yep. So dose, we have two different doses. So when people call me to ask about sizing and what they should use, we have the first question I say, is it indoor or outdoor? If it's outdoor, we only have to worry about disinfection. We don't have to worry about the combined chlorine and the odors in the room because that's outdoors. And one blast of wind and you don't worry about the odors and things like that. So the first thing I ask, is it indoor or outdoor? If it's indoor and we're worried about the combined chlorine, the mono, di, and trichloramines, then we use a dose of 60 millijoules per centimeter squared. If it's outdoor, we use a dose of 40. So just to kind of bring all that into balance for you, like Dasani and all the drinking water companies don't even really need to go there. They use the 40 dose for water that they drink right out of the bottle. So the dose of 60, you're getting the same thing. But again, keep in mind, you've got a 200,000 gallon pool, and the UV is only as good as you getting the water to the light. So the water that's out in the pool right now may be contaminated or have some things in it, which is why we have chlorine all the time floating around in the pool. The UV is secondary disinfection, so it kills anything that the chlorine doesn't handle, but it only kills it in the tank and sends the clean water back out that way. But with a spray pad, it's a little different. So we use a dose of 40 for outdoor and 60 for indoor.
Awesome. And it's like chlorine's little helper there. Kind of like the elves are Santa, like the elves are Santa's little helper.
Right. And I always tell people when they ask about, the pool, they say, well, if you're only treating that and there's still stuff out in the pool, we leave the UV on 24 hours a day, 7 days a week on the big pools, because it takes, with the turnover rate, it's 3.5 times the rate. So if you're on a 6-hour turnover, it's 22 hours before every single drop of water gets treated by the light. So we want to leave it on all the time. Even if there's nobody swimming, that water has to go through there and get disinfected and cleaned up, so that when you come in the morning to your facility, the combined chlorine should be between 0.0 and 0.1, because all that water has been treated. So that's another little,
Thank you. It's such a neat technology to talk about. Years and years ago, it wasn't used as much on aquatic facilities. Right. I know I've heard about ozone as well, but we're talking about UV here. But I know ozone is secondary disinfection as well. How do we compare ozone and UV, and what are the benefits of using UV? Right. And maybe what are the downsides, depending on what type of facility they're going to have?
Yeah, they're both great oxidizers. Ozone is a great oxidizer. I don't know if I could be talking right in your wheelhouse or way over your head. I don't want it to go where it causes people to be uncomfortable. But ozone is, you're taking oxygen, which is kind of 2 molecules of oxygen, it's O2. And to break that apart, you have to use an electrical current. So they call it corona discharge. So there's like a crown-shaped section of electricity, and as the air goes through that, it breaks that apart from O2 into individual oxygen atoms. And they're very radical, so they want to combine with another set of 2 to make an O3, which is ozone. So you've probably heard in the public about ozone, the ozone level this and the ozone level that. Ozone is a great oxidizer. So when they inject that into the pool, it oxidizes all those particles just like the UV does inside the tank. The ozone does it in the water, so it attacks the oil and the urine and the sweat and things like that. So it's a great oxidizer. The problem is it doesn't stay in the pool, because as soon as those molecules go in there, they want to reattach to something else as well, and it becomes oxygen and just kind of gets oxygenated off of the water. So it doesn't really have a long staying power inside the pool. And their contention is, well, neither does UV. You only kill what's inside the chamber, which is true. The big difference would probably be the cost. The cost of ozone can be up to 2.5 times as much as the ultraviolet light. There's a lot of maintenance and a lot of upkeep and things like that go along with it. It's a great product, but it's very expensive. And the longer you have it, the more expensive it gets.
What about chloramines or combined chlorine when it comes to UV?
So the UV that we talk about with the dose, the UV, if you use a dose of 60, can take care of the chloramines, and there's 3, mono, di, and trichloramine. So each one of those is taken out by a different wavelength of light. Trying to think real quick. Okay, so at 245, you can get rid of a monochloramine. At 297, a di, and at 340, a trichloramine. That's why we use the medium pressure instead of the low pressure, which we talked about earlier on. So medium pressure, you get all 3 of those taken out. The di and the tri are a lot more severe when it comes to the odors in the facility. So the UV breaks that down, just like it breaks down all the other contaminants that we talked about. It'll break down the combined chlorines also, and it puts back in nitrogen, oxygen, and hypochlorous acid after it breaks those down. And the hypochlorous acid is a form of chlorine that you use, just like if you would use the liquid or the tablets or the salt system to make the chlorine. So it's helping you a little bit with that too. So it breaks all 3 of those down, mono, di, and tri, as it goes through the light.
Awesome, thank you.
Sure.
So how effective is UV disinfection against our lovely protozoan parasite, Cryptosporidium? It's our favorite there.
Right. So what I told you was that, we give a dose of outside 40 and inside 60. So crypto gets taken out with a dose of 17.7. So we're going to kill that every single time. The other one is E. coli I think E. coli is 16.2. And that's another big one that everybody talks about. So E. coli and crypto are the 2 biggies. And again, you can use low pressure systems if all you're worried about is disinfection. If you don't worry about the mono, di, and trichloramines, the 254 wavelength low pressure systems are just as good.
Right. But I think that a lot of our aquatic facilities battle both. And so the training
without
for
question.
both would be an awesome thing.
Without question, yes.
Established in 1947 and part of the Bream family of brands since 1985, Raypak is a globally recognized and trusted name in the heating industry. We manufacture high-efficiency boilers, water heaters, and pool and spa heaters for commercial and residential applications at our Oxnard, California headquarters. With over 450 dedicated and passionate team members and 150,000 square feet of manufacturing space, we're always working to provide innovative solutions that meet our customers' high standards for quality while maximizing performance and reliability. Our state-of-the-art Innovation Learning Center serves as a training hub and collaborative space for engineers, representatives, wholesalers, and contractors. The ILC is equipped with the latest digital technology, a large lecture room, and a live demonstration and instruction lab for hands-on learning so you get the most out of your training experience. We understand the importance of comfort while you learn. That's why our ILC features an inviting customer lounge and break area with interactive product displays where you can learn about our full product lineup. The ILC is the perfect setting to learn everything you need to know about Raypak products. As a member of the Bream family of brands, Raypak is committed to Bream manufacturing sustainability goals and taking a greater degree of responsibility for future generations. By 2025, Bream will reduce greenhouse gas emissions by 50% and achieve zero waste landfill for global manufacturing operations. At Raypak, we demonstrate our commitment to sustainability throughout our company and our value chain, from innovative, sustainable product development to our proactive and responsible manufacturing processes. Every member of our team practices sustainability every day because we've seen how small differences can make a big impact. Our products are designed and manufactured in the USA at our Oxnard headquarters. Our manufacturing facility features cutting-edge automation technology and robotics to ensure precise, controlled production of our boilers, water heaters, and pool and spa heaters. At the end of the assembly line, we test every unit and document quality checkpoints to ensure safe and reliable performance before shipping products to our customers. Our innovative solutions, designed by our team of engineers, are built, tested, and perfected in our engineering lab prior to manufacturing. In 2018, we completed a multi-million-dollar renovation to double our lab size and increase our testing capability. Equipped with 17 test stations, an environmental ambient control room, a wind test machine, a burst test chamber, a 3D printer, and more, our engineering lab demonstrates our commitment to both innovation and quality assurance. Raypak's engineering team has filed over 35 patents since 2019 and continues to develop cutting-edge advancements in boiler and water heater technology every day. Our talented associates have a wealth of engineering, design, manufacturing, and service expertise to support your needs. We are dedicated to delivering exceptional solutions from custom to stock products, and we are conveniently located in multiple locations across the country to provide solutions and support when and where you need it. There is no better time to partner with Raypak.
Can UV disinfection systems be used with an oxidation reduction potential controller, ORP controller?
Yes, so different systems, and the one that I sell from Aquionics is one. There are several other systems that talk about that. There are pluses and minuses to that. So our system has, for lack of a better term, we'll just say cruise control like you would have on your car. So we know that we want a dose of 40 or 60, indoor or outdoor. So if we're on an indoor facility, we set it for 60, the light is a certain brightness. And as the controller tells it, hey man, the water's either getting dirtier or your light's getting older, it makes the light brighter or dimmer to accommodate to always keep you at that dose of 60. When you set your car at 60 and you go up a mountain, you go faster. When you go down a mountain, you want to go 60, it just kind of holds you back a little bit. Same thing. So our UV does that. Other UV systems like to say, we want to wait till the controller tells us that we need to have more UV, and we ramp it up according to that. My argument to that is always, I told you with the laws of dilution, it takes 3.5 times the turnover rate. So if it's telling you that your combined chlorine is over the required, by the time you turn that system up, it could be 20 hours before you do that. So we like to set the baseline at 60 or 40 and just leave it there all the time. So our system goes up and down, makes the light brighter and dimmer to accommodate the water quality all the time. But you can run it through a controller. It's everything. Everybody loves automation these days, so we can tie the UV system in with a controller for sure. We don't like to do it every single time, but there are some with automated filters where you have to turn the UV off, and it may do a bump cycle in the middle of the night. So you have to be able to control that, and you can turn the UV off, turn it back on, things like that. So we definitely can do it. All the good companies can do that with a controller. Some of the other companies don't like to do it, but it's definitely capable. Yes.
How does it work when you have ORP controller, you have your primary chlorine disinfection, and then the UV light? How does that work with the controller?
So the controller has to tell the UV, you set all the parameters, and like I said, it's all based on that dose. So when the ORP is a certain level, it'll tell the UV to either go up or down, that it needs more light or less light in the tank. So it can kind of coordinate that with the controller.
And it's basically, is it kicking in when maybe the chlorine's not keeping up, or is it based on the chlorine level at that point?
So the chlorine level is totally independent, which is another reason why we don't like to, I don't want there to be a problem with your chlorinator and it's turning the UV down or off or way high because of another piece of equipment. I trust, and so do the other UV manufacturers, that our product is doing what we tell you it's going to do, independently of the heater, the chlorinator, the filter, and all that. But you're exactly right. The pool chemistry is what dictates to the UV, if you're running it through the controller, how it's going to ramp itself up and down with the ORP.
Okay, awesome. And is there any new developments in the technology with UV disinfection?
Yeah, so it's pretty exciting. I mean, I always tell, my kids always ask, about what I do. And I say, look, I sell light bulbs is pretty much what I do. The light's either on or it's on. And I wish I could tell them that I was the one to design the water slides at the water park that they get to have all the fun on. But the disinfection is no fun. It's in the filter room and nobody sees it. They see the pretty slides and the water features and all that stuff. They never get to see the stuff that keeps them safe inside the filter room. But the biggest thing that we're doing now is we're using, so right now I told you our lamps have a single drop of mercury in them. So we're going to the mercury-free lamps. That's the newest technology. Which is great. We've never, knock on wood, we've never had a problem with a lamp, breaking and sending mercury out to the pool. We've got preventive measures to stop that. But the mercury-free lamps is a really great thing for us. The other thing we're doing now with the COVID being brought about, I told you we treat any kind of water. Well, you can treat the air in the HVAC systems with ultraviolet light as well. So you put it in there, and as the air passes through, it kills all that. They use it in operating rooms and all the government buildings and things. They've been using it like that. But that's a little bit exciting for us now because we've got a product to market for the air handling and things like that, which is, still in the UV. But again, we treat so many different things. When I first started, they said, one of our biggest customers was Campbell's Soup. And I said, well, that's kind of weird. They run the soup, through that UV. And they said, no, that's not what they do. They said they send the empty containers under a UV light so that they can make sure that there's no bacteria or anything in that container before they put the soup in it. So Coca-Cola does that. Intel is a big customer of ours. So when they make the processor boards, the water that they use to rinse the acid off the processor board has to be ultra pure water. So they use UV for that. So any industry you can think of uses UV for something. I just happen to be the one that gets to work with you on the pool side. That's all I really I don't get to go in any of the other fun places. I get to stay with the pool.
I have one last question for you, and I know it's one of the issues that can affect UV systems, and it is turbidity. So if the water is really cloudy, then that's the one downside that can keep a UV system from working properly, correct? And what can a customer do to fix that or correct it, or is there something new that you guys are doing to fix that problem?
Yeah, so one of our systems, we've got a new system. So we've got validated systems that are US EPA, third-party, independent validated, and then we've got our standard systems that we've been using for years. With the validated systems, what we have is we've got a baffle system and a baffle plate so that you've got the turbidity and there's a lot of bubbles and things like that. So when the water comes into the tank, we can kind of get the water spun around the way we want it and get it in a certain laminar flow so that when it goes past the lamp, it takes care of that. It's not 100% effective, but the turbidity in the water is something that the pool operators have to deal with. It could be, most of the time it's a pump or something that's cavitating, that causes the turbidity. So yeah, there's really nothing that we can do. We're trying to work with the different operators to do, but that baffle plate seems to be the best solution that we have right now for taking care of that.
That sounds neat. Well, thank you very much for being on my podcast today, John. It's been a pleasure having you today and talking about UV disinfection in our aquatic facilities.
Well, thanks for having me. I really appreciate it.
You have a wonderful day.
Thank you, and you do the same.
Thanks for diving in today with the Let's Talk About Pools podcast. Be sure to follow us on our YouTube channel or our Facebook page. And feel free to rate, subscribe, and leave a review wherever you listen to your podcasts so more aquatic professionals like you can learn about the show. We appreciate it, and we'll catch you in the next episode of the Let's Talk About Pools podcast.